My grade school experience with technology was primarily with presentation technology, such as an Elmo projector and PowerPoint. It was seamlessly incorporated into teaching the content on a daily basis. Manipulative software programs, such as Geometry Sketchpad, were used much less frequently. Now that I am a pre-service teacher, I am eager to learn how to use technology effectively to engage my students. When used appropriately, technology is an excellent resource to benefit instruction and enhance student learning. To that end, I have learned and mastered how to incorporate graphing calculators and software programs such as Geometry Sketchpad and TI SmartView into my instruction, as well as presentation technology like a smartboard and Elmo projector. When I began planning my mini unit for my 5th period honors calculus class, I wanted to utilize programs I already knew how to use or learn to use a completely new program. My coordinating teacher suggested a lab using motion sensors. I wasn't sure how it was going to work, but I got excited about the idea and wrote a lab based on data collected through Calculator-Based Lab, or CBL, motion sensors. I intended the lab to review running a regression, sketching a function, and the relationship between a position and velocity function. This lab then introduced the topic of evaluating area between two curves. This lab project was an effective use of technology because it was novel and interesting, it gave students ownership of the collected data, and it provided a real-world example of how calculus can be used. The first part of the lab required student groups to set up the CBL motion sensors and connect them to a graphing calculator. This way, students could directly and immediately import the data collected. Then one student member rolled a gym ball towards the motion sensor for multiple trials. Next, the group used the collected data to run a regression test to find a position function of the ball over time. Groups were then asked to take the derivative of the position function, graph it, and then evaluate the integral to determine the distance traveled by the ball during the first 2 seconds. Differences in the distances on that interval could be explained by the speed at which the ball was rolled. To evaluate the difference in distance, students were asked how they might set up an integral. Most of the students had very little trouble using the technology. They easily set up the motion sensors and ran the program to collect and import data onto their graphing calculator. One group, however, could not get a good connection between the motion sensor and a graphing calculator. We troubleshooted that problem by giving that group another group's collected data. The biggest drawback concerned the balls. I didn't think ahead of time to collect the gym balls after the groups were done collecting their data. In the future, I would set a time limit on data collection and then collect the gym balls immediately after that time. I would also have sample data or a sample position function for any group that was unsuccessful at the data collection, even though the data collection is the technical aspect of this lab. I learned a valuable lesson on the importance of classroom behavior management when using technology. Additionally, I learned that I need to plan for groups finishing at different times. 2 groups finished with 20 minutes left in the period, and other groups took the entire period to finish the lab. In the future, I would absolutely use this lab again. The technology used in this lab had an engaging effect with the honors calculus students. Additionally, I thought it was a good connecting lesson on area beneath a curve and the area between 2 curves based on a physical model.